All right, good afternoon. So, like Jerry mentioned, we're going to have a little bit of a rapid fire here. We talked a lot about digital project delivery, saw kind of presentations, whether it's from kind of the asset owners or for contractors or other organizations that work in the field. But now let's take a look at what solution providers are, in the marketplace, what they're offering and what they're kind of looking at to add value. So first up, we're going to have Scott Benesh from VEERUM. Scott is the VP of Capital Projects. So Scott, please come on up and introduce yourself a little bit.
Hi. Yeah, my name is Scott Benesh. I'm with VEERUM, the VP of Capital Projects. I'm one of the co-founders. We're a Calgary-based company. We started 8 years ago, and really as a group of people that came from the industry. I spent 28 years as a project manager, construction manager, engineering manager. And we decided we needed to get technology into the way that we built projects. So we formulated a few solutions, brought in some digital technology, and we'd just like to share that with you to sort of spark some ideas that you may have about how this can really help you. So really, if we talk about digital information or information, you really started on the left-hand side. Years ago, it was people-centric. So you had people that were really the ones that managed all the information, and you relied on the people in the field to do things. And then really document-centric. So people would get documents together. Interesting, 35 years ago, as a junior engineer, my first job was document control engineer. All right? Lots of fun. Woohoo! Just tells you how good my grades were in school. That was my first job. But so it was, I got to touch every single piece of paper, put together these huge binders. The binders got given to couriers and sent off to the owners, and they sat in who knows where. And then we went to data-centric, and data-centric is good. That's the first start of getting your information sort of coordinated there. And then then we move to more of a spatial 3D information where people can access things through an environment where they really understand, and understand the context in the 3D visualization. So that's really the progress. It's really interesting to note that 90% of information is transmitted to the brain through visuals. So if you can see a pump, you're gonna really understand that that's a pump rather than just seeing a tag. Visuals are processed 660,000 times faster than text. So if you can see it, you're going to really understand it. And then you retain it much better as well. So it's just getting into that 3D information mode. So now I'm going to talk a little bit about digital twins. Now, digital twin is I still can't get my head around what it is, but I think it can really be any kind of digital representation of reality, whether it's that physical reality or the data, operating information, document management, any kind of thing that represents reality. And that digital twin can really live with your facility. So when we started VEERUM, we really focused on the construction and creating that digital twin that will help you to facilitate your construction activities. But then it morphed into, well, we're really getting some good information together. It can really live with that facility. So it's that digital representation of your asset that lives alongside the physical asset through its full life cycle. All right? So, what we're going to show you here is how you can be on site without going to site. But even being on site, let's say you wanted to go to site to do some work on it, or you had some maintenance planning or some maintenance work. You'd go to site and you'd see things, but you wouldn't really know what you're looking at. You'd still have to get the information. So can we create this really digital, rich environment where people can visit site just through a web browser or in virtual reality, but they can also access all the information about it, all this digital twin information. Can we aggregate it all together into one cohesive environment? Okay. So really, as a as a digital organization, the questions you ask yourself, is my data available, accessible, complete, organized, accurate? These are all things that you guys are asking constantly, and that's really the problem that we're all trying to solve here, and make it accessible, understandable, and improve the way that we do work. So how can we do that? So on the left-hand side here, you'll see you have all these different asset information sources. You have your 3D representation of your facility. Now that can be a CAD model, a BIM model, Revit. That can be a laser scan. It can be a drone scan. It can be a picture. Anything that shows that 3D representation. You got your project plans, documentation, any kind of data sets, operating and maintenance information. That's all really good information that a lot of programs do very well. But they're traditionally, some different people or different organizations do different things very well. If we can bring all that together and connect it all on the left-hand side, regardless of the format, regardless of what it looks like, where it comes from, as long as it's somewhat digital and searchable, we can connect it all together. So you can connect your reality, your CAD models, your documentation, your real-time operating information, and then you can start to leverage that to solve your business problems, right? Artificial intelligence, machine learning, to start to coordinate and look between these data sets and work it into user stories and day-to-day activities. And then you can really start to solve some of the problems that you have. Okay, so really, what are some of the trends in this digital transformation? So an interesting fact, 10% of today's enterprise programs are on the cloud. They're predicting 50% by the end of this year will be moved onto the cloud. So the cloud, what it really does is it allows you to manage these huge data sets which are not really possible on local servers, or they're not accessible to everybody. So security has really come a long ways on the cloud, so that more and more companies are comfortable to do that. So if you can get everything on the cloud, it makes it accessible to everybody, anywhere. Reality data capture. So what I'm going to show you is how you can use reality data capture to really augment and improve your sort of 3D visualization and access to information. And what that the reality data capture is really a commodity now. You've probably heard of laser scanning, drone data capture. How do you leverage that to improve your digital twin? So now even I or you can laser scan a facility. You could laser scan this. I could laser scan this room with a handheld device in about 15 minutes and get a really good quality digitization. The iPhone 12 has a LiDAR scanner on it. So I'm really envisioning a day when somebody modifies a facility, they take out their phone, they scan it, upload it. Now you've got an updated 3D representation of your facility. So that's coming very quickly. And we really want to empower people to work anywhere, anytime. And the last 2 years of COVID has really, really highlighted that, where people can't always go to site. People want people to work remotely in different areas. So how do we get people to be able to, do their job that they would have traditionally done on site, but do it remotely and do it effectively, and probably even better than they would have on site, because all the data is in their hands, right? And really, agnostic is really important. That's something, there's so many different data sets and data types and data, that if you can really aggregate any kind of format into one common viewing environment, that's going to be very important, because there's a lot of good solutions out there that need to talk to other solutions to get the most out of them. Right? So just one of the artificial intelligence, machine learning algorithms that you can do. There's multitudes of them. So really the way that for construction and engineering, if you have a digital twin of what you want, which is your CAD model, right? That's your BIM model. That's what the engineers put together. This is what I want. Now, if you can digitize your construction site periodically, daily, weekly, monthly, then you have a digital representation of what you have. When you match those two together, the computer can tell you what's different. And that's really what a project team does. A project team is to make sure that reality matches your plan. So if we can do that, so what you can do is you can digitize a construction site very quickly, periodically. Normally we do it once a week. Within 48 hours, we've matched design to reality, do quality reports, tell them, is something built incorrectly or not? We tell you right away, and before you cover up that wall, you'll be able to see it, you'll have a digital record of it, and we tell you if it's installed or not. So if it's installed, so this just gives you an example. Everything green here is installed within tolerance. Everything red is missing, it's not there yet, and what's yellow is there, but it's out of tolerance. So you can see that it's there, but it's wrong. It tells you right away so that you can go and fix it before it becomes expensive to fix. Because a lot of these cost overruns are really from rework on projects late in the game when you're under pressure. So if you can identify issues right away. So this can feed progress reports and such. So this is just one example of how this digital twin technology can help in project execution. So I'm just going to play a video here. So I want you to think about your BIM model, your digital model. There's an old facility, you don't have a CAD model, or a facility has been built with 2D drawings, so you don't have a CAD model. Well, what you can do is you can laser scan your facility. And like I said, the laser scanning technology is becoming very fast and very, very good. And then what we do is connect tags to each component in that laser scan. And that's the only thing that's done manually is you ingest a tag list, a plot plan, maybe a P&ID, and you drag and drop tags onto each component. And all of a sudden you've got this 3D BIM model of an old facility or a facility that you didn't invest in this CAD model, and people believe it because they can see it. Now it's semi-manual now, but artificial intelligence and machine learning is being developed right now where you ingest a laser scan, a plot plan, a P&ID, and out spits a smart BIM model of your facility that anybody can access through a web browser and get to all their information, work orders and such. So here's just a little video of one facility where, it's a laser scan, you click on a pump, and all that's been done is that tag has been connected to that pump. We developed APIs which connect to your real-time operating information, and this is just through a web browser from anywhere. Over here on the left are the different data sets that you can create APIs into to draw it into this information. So all the different digital information about this asset is at your fingertips, and it's accessible through a 3D scan, right? And you can do different searches, you can look up work orders, you can really access whatever information you have in your other systems of record. Because you might have a lot of good little systems of record that only certain people have access to, or you need a subject matter expert, maybe you need a license. What we do is create an API between the digital twin and that system of record, and then draws it in so it's all coordinated. So when you think about data quality, the two things that people normally do to improve their data quality is one, make it accessible, visible. So now I can see it, I can see if there's something wrong with it. And then two, you match it all to the other data you have. And if there's a mismatch between data sets, you know that you have an issue and you can fix it. So it really helps in facilitating that data quality management and bringing it all together and being able to see it and access it. Because, older people on the construction site love this because they can see the pump, they can go and click on it. They don't need to get into a database to see things. So anyways, that's the end of my presentation. Thank you.
All right, thank you, Scott. So we're going to ask Scott a few questions. So if there's anyone in the audience, just put your hand up and Jerry will come up to you. But in the meantime, I guess, Scott, what I really want to understand is you've already implemented it. You're offering the solution to the marketplace. And I guess, could you share a story of a client who maybe jumped on board with VEERUM that was more traditional, and now that they're using your solution, what is some of their kind of feedback and realization there? We heard a lot about ROI and kind of driving that value. So it'd be really cool if you could elaborate on that.
All right. So we start out in construction, and really being able to digitize and get that construction, they've really reduced their rework, meaning they know that it's been built correctly. They know that they don't need to go and do a bunch of rework, so that's really helped. And they know that their progress reporting is correct because it's digital. And I don't know if anybody's been a project manager, if you've ever had a progress report which was inaccurate. I'd be amazed because I've had many of them. This makes sure it's digitally accurate. So it means that they know when they're falling behind schedule and where they're falling behind schedule so they can fix it. And second is really operations and maintenance. There's a lot of clients here in Calgary and around the world who are relocating their people from on-site to remote locations, like from Fort McMurray down to Calgary, and they're able to do that work. And really, they've seen 30–40% productivity gains in maintenance planning, in operations, and any kind of work that you need to get that information right away.
Awesome. Thank you, Scott. Any questions?
I've got a question. Jerry said I'm only allowed to ask one question. Just real brief. I think the platform looks amazing. I think it's a great idea to use LiDAR as an alternative to building models. It's probably way faster for existing facilities. And tagging is probably less work than building out a model that's accurate. The LiDAR data is a separate data file, which the client would have separately. The database of all the assets, they'd have that separately. The effort to tag lives in your system. Are your tags exportable? Can you pull that out and map that to like an IFC file? Can you move that effort around? Absolutely, yeah.
You can export the information from our system in any format you want, in CSVs, in reports. Like you can say, show me all the pipes where have been hydro tested or that need maintenance in the next month. You'll be able to see it. And they also say export a report of it all. So that comes from other systems, but you can access and get those reports, from our systems. We developed that live API. So it's not just a snapshot, it's constantly being updated. So it's an actual live information source from there. So, yeah.
I have a question. Is your platform having capability for troubleshooting operation? Because it's great to know where the assets are located and all those things which you presented. It's absolutely marvelous. And but most clients are always struggle with operation of the system, especially when it comes to more sophisticated installation.
So you mean while it's operating in the operating phase?
That's correct.
Yeah. So I don't know if you saw, like we do bring in live operating information from the field. So that information, which is normally just sitting, the guy in the operator's room, has that information in front of him, and he can see it in a graphical representation. We bring all that and attach it to the 3D representation. Instead of seeing a pump on a graph, you can actually see it in the field. So yeah, and if there's alarms, we can highlight alarms. Like all of a sudden, a pump will turn red if there's some sort of alarm in it. So to be able to troubleshoot operational issues is really improved with having that full 3D visualization of any kind of operating issues. Okay, so if a valve fails or a PSV fails, you can, within seconds, you can see it and say, wow, it's way up in the air. We better get a scissor lift out there, or we better get scaffolding going. So right away, you can react to any issues because you have that 3D realistic visualization of the facility. And you believe it because it's a laser scan. It's not a CAD model. It's an actual laser scan. So yeah, it's being used for those purposes, for sure.
All right, perfect. Thank you so much, Scott. And one last thing, I guess VEERUM is a Calgary-based organization and company, and they're one of the successful startups that not only are looking at the architecture, engineering, construction space, but also in the the technology realm. So that big shift that we're seeing within Alberta and within Calgary particularly, VEERUM is a very good example of that. So very impressive. Thank you very much, Scott. Thank you. All right, up next we have Derek John Mullassery from CopperTree Analytics. Derek is actually the Director of Technical Operations. How you doing? All right, and then here's your clicker. Awesome.
All right. Hope you guys are doing well towards the latter part of the day, I know, but be engaged for another 30 more minutes, I guess. And I'm excited to be here, actually. It's been 2 years of staying at home and working remotely, and finally to see some familiar faces. PCL is here. They're a partner of ours, and good to meet some new faces as well. So my name is Derek, and I'm with CopperTree Analytics. We're a building analytics company based in Vancouver. We've got an office in Seattle as well, and we've been around for the last 10 plus years now, and we help our clients improve their building performance and help them reduce energy consumption. I've been with CopperTree for about 8 years. I run a team of engineers and analysts who work on building data. We've been talking about data for a bit now. We work on that data and identify energy savings opportunities for buildings. So let's take a look at what we are talking about. Now, why is it that analytics is important? Why is it that we are in the business? Now, HVAC systems, as you know, they're very complex, not only to install, but also program and commission. Now, many organizations carry this large deferred maintenance liabilities. Energy is expensive, and maintenance is expensive as well. I don't know why, I'm shaking a bit. Now, facilities is understaffed and don't know where to and how to prioritize. But we come into the picture and we help reduce that organization's bottom line, expenditures, and enhance building performance. Now, building and energy analytics goals. What we want to do with buildings is increase the energy efficiency. We want to improve occupant comfort and safety, and then reduce the maintenance costs, thereby prolonging building equipment lifetime and plan capital upgrades. We also want to work with partners like PCL and other companies to help them with commissioning activities, to analyze that commissioning phase and help improve the overall process. Now, how does it all work? Let's look at a building, and this is a sample kind of infrastructure that you find in buildings. You've got the general building automation system, and then to this, you add a small device that can collect the data from the building automation system. Once you collect that data, then essentially what you do is push that data to a cloud service that goes through a secure firewall, and then all of that data from the building automation system is available in the online cloud server. From there, in the cloud server, you can then add more analysis to that. This data can also come in from an API integration. It does not necessarily all just need to be from a building automation system itself. It can be an API integration whereby you're basically pulling data from a data lake. It can be some other type of building automation system. Once that data is in the cloud, then we analyze that data. We implement multiple different algorithms on it, and then we get to the results that our clients really are looking for. Now, how does this all really work? Essentially, what you're looking at is 3 main phases. Okay, so first we collect the data, and the data itself is integrated to our platform through that integration process. As I said, it can be a building automation system, it can be an API, data lake, whatever that is. After that, we then move on to the mapping and contextualization phase. That's where it really gets interesting, because now you have data from buildings, but now that very data needs to be grouped, it needs to be tagged, it needs to be, unnecessary points need to be removed so that it's not included in the analysis. All of that good work happens in a mapping and contextualization stage. Within that particular phase, you tag the building's data as well. Once you review it, approve it, you feel good about it, that data then, it's really a subset of data, that then moves on to the next phase where analytics is actually applied on that data set. We apply automated alerts, energy-related alerts, all of that is included in that FDD implementation phase. Now, when you do implement a project like this, what exactly can you expect? this is a sample story. And you can think of buildings that you own and operate, think of buildings that you're aware of, and you can see generally what to expect from an analytics project like this. This one here is about 185,000 square feet building. The annual energy savings realized after having deployed analytics is about $230,000 per year. Now, I know the building itself is small area-wise, but really what you're looking at is a very energy-intense, high-density building. For a building like that, you could still have $1 million worth of energy expense sometimes. And now, reactive maintenance reduction is about 40% year over year. So you start with, this is what I have really in the building. Now in the next year, my maintenance hours have reduced because I'm now using a tool that allows me to tell me exactly what systems are problematic. I don't need to waste my time on systems that are performing just fine. And then you have indoor comfort KPI, occupant safety, occupant comfort, that's important. And that can be improved by about 54%. At the end of the day, though, we need to make sure that we make money or save money from these projects. In this case, the client invested about $37,000, and the payback was in a matter of a few weeks, really. It's 0.165 years on energy savings alone. So you can see the rate at which you can actually save energy on these buildings. I did want to include this slide precisely because I know that a lot of you here, you're involved in the design and construction phase, and operations is something we haven't talked about much today. But even in the design and construction phase, the analytic platform has a role to play because you can think about what is going to happen with all of this data in the operation stage, so you can plan accordingly. In the construction phase, really with commissioning, let's say to begin with, you can validate control sequences. You can make sure that that commissioning process itself is carried out correctly. And then in the operations phase, that's where the building is operating. You have occupants in the building, and then you use analytics to make sure that the performance doesn't drop. You have a good building. Here is the model that you had, but is that performance dropping at all? You have something to look after this operation 24/7, and that's really the role of the analytics platform. I have a few slides here. I'll run through this quickly. The idea here is to really show you what all of the data that we talked about earlier today really looks like, because we talked about air handling units, and we talked about these tags that are applied. At the end of the day, all of that information becomes very useful to the owner in the later parts of the project, right? Once the building is occupied, let's say. In this case, you can see some transfer fans in the building. All of them were running 24/7, very low-hanging, right? Low-hanging fruits, really nothing much to change except implement a schedule. And you start implementing a schedule, now you're actually saving tons of money just by that. Another example, from very simple, easy to fix things, you can then go into much more analytics-driven HVAC sequence upgrades and things of that nature. This is where I know someone had a question earlier about how does this really help with operations of a building, right? You're looking at 3 dampers in an air handling unit, and you're looking at things like enthalpy, you're looking at outdoor air temperature, you're looking at how much ventilation is required in the space, and the analytics can then tell the operator to improve the sequence by which the damper is opening and closing. So you diagnose the root issues, and then you prioritize those issues by not just saying there is an issue, but by associating a cost to that, right? You tell the client that this air handling unit is costing you $8,000 compared to another one that's costing you just $4,000. So there is prioritization of issues that happens by attributing cost to it, and it could be other prioritization metrics too. Think about, if it's a zone level system, you have 500 VAVs, more than the cost, you may be interested in the comfort that the occupants are experiencing. So in this example, just from 3 air handling units, you're saving about $9,000 a year just by improving the control of the dampers in the air handling units. Now from that, analyzing all of that information, you then move on to the next page, which is KPI reporting. And in the reports that you get, essentially you're looking at just the things that matter to you. You don't need to go through a bunch of documents to find out what the problem is, what needs to happen. You're looking at, out of all of my VAVs in the building, in this case, these are all ACUs in the building, what are the ACUs that really have an impact in terms of energy and expenses? And those are the ones that are listed here. You then know that if you have staff in the building, they can be led to just those ACUs and they can work on just those. Why waste your time working on the ones that are performing just fine? And these reports are automated. You can get them in your inbox. It's weekly, monthly, quarterly, whatever you define, you get that, and it comes with all of the associated metrics as well. This is an example dashboard, just so that you can see what this could look like in a real-life setting, in a real-world building. I've anonymized the page, but at the end of the day, you have alerts. On the top of the screen, you can see the different insight categories. So you're looking at fault detection diagnostics-wise, there are 31 insights. And then right below that, there is realized savings to date. That is, how much money has been saved to date using analytics or from other ECMs, energy conservation measures, implemented in the building, right? And that starts from, it's a cumulative sum kind of trend. You keep tracking that, making sure that there is improvements happening in the building. And at the same time, there is new and upcoming opportunities that will be quantified as well. And there is a dollar value that's associated with those findings too. It's kind of what you can expect once you implement analytics in the building. I did want to add this slide here in a closing couple of slides. What's really important in all of this is you've got the technology, but there are a couple other things that have to play in the mix. One is resources, and the other one is culture. Why? And that's because you can have a really good tool that's able to do a lot, but you need to maintain a culture in the organization where people actually care about this. People care about continually progressing and improving in sustainability and energy conservation. And that's really paramount, and then there is resources. Having the right talent who has the expertise and the skill sets to do this, and all of these three things then come together to make sure that you have a very successful data-driven analytic approach, facility management approach for your buildings. Then lastly, at CopperTree, we join with our partners and our clients to help them with exactly that. So it's not just the technology that you offer, it's also a variety of services. Starting from, I have a building, I don't really know what to do, I need to make sure that analytics are deployed in the building. You basically then start with, okay, let's plan out a project, let's bring the right data in, let's deploy the device. All of that turnkey implementation solution is offered by CopperTree. And then we provide ongoing managed services. After the entire project analytics implementation is complete, what can you do on a month-to-month basis? How can you still leverage the results from analytics and use that in your operation of the buildings? And then provide support to our partners and clients so that continually they can take advantage of solutions like that. So thanks for making time for this. Appreciate it. I guess awesome. Now it's time for questions.
Yeah, and you're not shaking anymore.
Oh, I know.
It's all good.
I don't know what happened there anyway.
But no, this was really interesting, and this is kind of a topic that in the industry has been becoming a little bit more commonplace. So EllisDon, for example, works on this for some of our projects with energy and digital services. We've seen kind of the need in the marketplace come up. One point that I want you to elaborate on, Derek, is how can we effectively leverage your knowledge and your company's kind of resources on the front end? You just slightly talked about that right now, but a lot of what we've seen today is about the planning, about getting a lot of that digital-driven design and kind of digital project delivery up front. So what are some kind of things the audience could take away here, maybe to their companies, to some of the project leads, of how they can look at operationalizing these kind of automated efficiencies downstream?
Yeah, I'd start with, most of you guys are, involved in construction. Think of how analytics can help you with the commissioning process itself, right? You have traditional commissioning happening in buildings, but what if now you have a tool that you can leverage on to make sure that that commissioning process is performed correctly? So think about, now you have trends from the building coming on, and rather than having techs go to each and every VAV box and doing that traditional sort of commissioning, you have data that you can rely on. And you don't need to do everything the same way you used to do. So it's really important to take advantage of that and think about, okay, how can I make sure that I minimize unnecessary labor and unnecessary investment of money on things that can actually be carried out by the software itself. So that's a big piece. The other thing I would add is, we all talked about processes and documentation, things like that. Think about a project where you're in the design phase, and one of the things that you can think of right at the very beginning, before you even get the controls vendor in place is make sure that in your contractor expectations, list down the things that you need. Points need to be named correctly. Only then can you take that data that can be extremely useful in the later phases of the project. I've worked on projects where you've got cryptic names, right? Everything on the screen looks really good, but behind the screen you've got points that are named X, Y, C, and it's really unusable. So thinking along those lines right from the very beginning would be extremely useful.
That's a good point there. Thank you. Any questions from the audience or online?
Nothing online as of yet, but I think we have one over here.
It's the same people.
Sorry. Yeah, just a couple, two-part question actually. With your system, are you able to kind of proactively predict failure on devices based on the data that you're collecting? Like, can you see a motor's starting to fail and then proactively go and fix it? And second part of this is, are you aggregating data across multiple clients so that you can predict the life cycle of a particular chiller or whatever, and sort of like trying to capture that data and publish that out to other clients?
Yeah, good
sharing data.
Yeah, good questions. The first one, with regards to, can you identify things that are going to fail? They haven't really failed just yet. But we call it preventative maintenance, right? And rather than being reactive about things, looking at data patterns and pattern analytics come into play then. Let's take the example of a motor. And if the amperage keeps going up and you know that the motor speed itself, it's been maxing out sometimes, that there is something happening with the bearing perhaps. And those kind of things can be flagged because now you have real operational data from the equipment that you can take advantage of. And that operational data is key. That's why getting those data points in the system becomes extremely useful. And things like fixing things even before it becomes a severe problem is very important in terms of operation. Otherwise, you can have a tool like this. What's the point if the tool is telling you that, oh, it failed after everything is a mess already? We want to catch those things before it becomes an issue. And I think the second question was with respect to, sorry, can you repeat that question again?
It's like sharing data across clients. So
yeah.
you identify that a particular motor fails at 50,000 hours.
Yeah.
Are you able to aggregate that across multiple clients and then have a shared database?
Yeah, before even we do it across clients, what you do is, let's talk about a university with 50 buildings. Now you've got one manufacturer's chillers in 5 buildings, another manufacturer's chillers in the other 10 buildings. Now you can actually get all of that data up, one level up, look at it and go, which chillers are more efficient than the other ones? And then help the decision makers know that these chillers are working better for you compared to the other ones. And then, yes, one level up would be taking that information and sharing it with, decision makers so that they can, again, at a portfolio level or an industry level, you can draw patterns in terms of what's happening.
Hammad, we have one from online, from Isabel. She says, maybe I missed the information, but I was wondering if the software is agnostic to any software already used by the building.
That's a very good question. Yes, we are agnostic in that you can have a Siemens system, a JCI system, you really name it, Honeywell, Delta, Reliable, it could be BACnet, it may be proprietary, it doesn't matter. A good analytics solution has to tie in with different types of automation systems and then generate results. So yeah, absolutely.
Thank you.
All right. One last chance to get your questions in here. Going once, going twice. All right. Thank you, Derek.
Thank you very much.
Thank you very much.
Thank you.
All right. So now we have Rick from BuiltSpace Technologies. He's the CEO of the company, as John alluded to earlier. So thankful that he could spend a little bit of time with us.
So first of all, I think we've had some great sessions today. I've learned a lot from John, from Chris, from a lot of the presenters, and I think they really showed some common themes. And to me, one of them that really stuck out was, a lot of stuff goes from construction into a CMMS. And I'm going to go out on a limb here and say it's time to stop doing that. We are using CMMS technology that's 40 years old. It's very, very manual. It means a lot of bums in seats for a lot of time. And, we need to now change that. And, we are building transformations. And I think that what Chris pointed out was that the solution that the 14650 is showing is for a common data environment that crosses handover and goes for the life of the building. And so if we start thinking in those terms, I think we'll see some amazing things happen. So my background, 25 years ago, I put construction information on the internet for the first time. That company is now Dodge Data and Analytics Canada. So we were managing about 1.5 million construction projects through North America in our platform. And the thing that was really stood out to me as I was bringing all of this up and bringing drawings and specifications, and we got into electronic plan rooms and the whole pre-construction side of things, was that there was a big black hole out there in existing buildings, and so 12 years ago I said we need to find ways to address that. So we founded BuiltSpace, my wife and I actually, and we said, okay, how do we get better data about those buildings after handover? So when you're trying to change things, we said, okay, do we go after the building owners and get them to change? And I think we're all sitting here today because that's a slow way to go to that. But where we did find a lot of interest was in the service providers. We obviously concentrated on HVAC, electrical, plumbing, and so forth, and developed a lot of expertise on how do the service providers actually do the work in their buildings, and how can we help improve that, and how can we take that data, including the asset data, the name, model, serial number, and so forth, and the service history, and put that into a common data environment that could then ultimately be shared with the building owners at scale. So today we are in about 28,000 buildings or so, and this should start. This is digital operations in 60 seconds, and I really just wanted to give you some examples of what we are doing, how we can visualize it, as I think it was Scott was demonstrating. Yes, that is easy to do today, to do, in this case, a 3D 360 camera, and it took a couple of hours to do this ice plant. They've tagged each of the assets, but the process that we really look at is taking and tagging the physical assets with QR codes or barcodes or other tagging devices, and it's getting ahead of me here, and then putting that data into a database, visualizing it, and it gives us a place where we can also put the IoT data. So there was a question earlier about the predictive analytics. There was a short session here on a product, a smart motor sensor from a company called Analog Devices, which is running on an air handling unit in our office, or next door to our office, and that was done as a proof of concept for especially with COVID, finding ways to make better data available for critical equipment. And so that has been a very successful implementation, and it's something that is integrated into our core platform. So most of our users are using a mobile device. They're in the field, they're on a construction site, and they're using these devices for different functions and different service delivery. So here's a quick example. You'll notice the animated screen. So in this case, we have taken an IFC XML feed from this project, which is in Ireland, I think, and filtered the XML data to specifically just the doors and openings, and put it into our application so that we can create a work plan to install doors as we need, for example. And one of the key things with this is that the property set that is associated with each element can be imported to the mobile app, available on field for viewing, but also for updating with a standardized procedure for the class of equipment that we're looking at, or the asset we're looking at. And because we've got the element ID from the BIM, we can update through our API back to the BIM. So that is another example of how we're transforming some of these processes. As I mentioned, the idea of a service plan or a work plan with multiple assets, which can be selected either manually or in a data-driven construction process, we can create a work plan for that equipment, and it can be sent to the field, to the trade contractor team that is doing that work, and they can together install VAV boxes or install doors or do roofing or whatever the service is by clicking on the equipment, saying I'm installing this particular VAV today, or scanning the barcode with the element ID on it, doing the work according to schedule and to process that is defined for that. And then at the end of that, when the submit is hit, we can update the construction progress and model. I think the most valuable assets in any building are people. And when we talk about value delivered, what we're seeing, it's not about maintenance, it's not about energy, it's about keeping people healthy and safe. And in the commercial real estate industry, right now they will do anything to get people back into buildings. So, but here's an example. Some of the properties that we can add to specific assets, and that includes spaces, is things like what safety hazards are there, what health hazards are there. And this is the most obvious one. I'm in an ammonia plant when I'm looking at this, and obviously ammonia is one of the safety hazards, but there's a lot of other hazards and environmental issues in this particular installation, and we can capture that data as part of our process of servicing things, so that the next person going in will be more aware of it. And as we're seeing more and more labor shortages, there's a great need to utilize your people as best you can, and so having them informed as to what they're walking into is one way to help that process improvement. So here's a few of the things that we work with today. COVID has really changed the people's priorities, owners' priorities. One of the biggest ones is cleaning and sanitation. The janitorial firm that was in our office and the building owner came to us and said, hey, we want to use your system. So we put that in. We're now rolling that system out nationally for this contract, or for the janitorial company. It'll be in about 5,000 sites fairly quickly. But indoor air quality, ventilation, energy has always been an issue. Just safety and safety compliance and cybersecurity are all other areas that we address in a single source of truth. It's a collaboration platform. So what that means is we can have, the energy meter company, the HVAC company, electrical company, plumbers, all working together in a shared but secure workspace. Each with their own workspace, but sharing the facility and the assets. A couple of examples of screens. It's highly configurable. You can set your own processes up for any type of work, for any asset class. And we're doing asset classes that we found there's not uniform MEC codes for them. It's a very dynamic situation. And that's it. Any questions?
Thanks, Rick. That was actually very enlightening to see kind of the end-to-end that you guys are providing construction into the FM side. I guess as we get the questions rounded up here, I was just curious, how do you see kind of that turnover? Say a contractor uses it during construction, and then say the client wants to use it for FM.
Yeah.
Have you been in that scenario?
Oh yeah.
Yeah.
And specifically for things like energy and water.
Use the mic, Rick.
Yeah, specifically for energy water meters. I think our partner in that area has done about 60,000 meters so far. And it's construction, installation, commissioning, handover to the building owner, or the utility is often the end customer in that case.
Thank you. That's very impressive. Any questions for Rick? John?
We have a question over here. Oh, John? I didn't see his hand go up. You have to put your hand up. I can't. I mean, this is how we do it. Is it you?
Hi, Rick.
Hey, John.
When you think about what you're trying to do with this platform, what are the risks? Like, what's the roadblocks? What's the hesitation that you're coming up against for adoption?
People's lack of ability to change. I think it's easier to do nothing, but the COVID pandemic has just disrupted the world so much that they can't not change anymore, right? So, all the things that you talked about, the labor shortages, product shortages, health and safety, if the commercial real estate industry can't fill their buildings, those buildings simply are worth a whole lot less. So, we literally exploded in opportunities probably 6 months into the pandemic. It just was, it's crazy. Now, 6 months ago we might be getting 3 or 4 opportunities a week. Now we get 3 or 4 a day. So yeah, it's crazy.
Awesome. One more question there.
Hey, Rick. Great presentation, amazing platform. Just wanted to understand, like, as in next steps, from a CMMS perspective, when you look at the next steps in terms of how do you transform the platform itself, do you think integrations with, let's say, something like a materials management modules, is that something that you're aiming to do, or is that something that's being considered as well?
So we have a very, very extensive API that, we've done everything from existing, ERP systems to building automation systems to energy metering platforms to other cloud platforms and even to directly to like Bluetooth devices that are in buildings, in fields, and so forth. So I think we are not in the business of being an integrator. We are providing a data infrastructure, a platform infrastructure to enable that within our partner ecosystem. And I do see construction as the natural step. I mean, we went into the post-handover side first to really make sure that we know how to do the services, and some of them are simple and some of them are not so simple. But then as we started moving back, the realization that, as John said, we need a digital twin that is high fidelity populated data that is maintained and changed. And I think one of the things that we will start to see is that the efficiencies we find in FM will transfer to the construction site as well. And it's a lot of it just visibility to, has that work been done? And if so, do we have the appropriate data that we need? And what's our progress? So I have an example. UBC is in their underground utilities, so energy and water, has about probably close to 10,000 assets underground. And so, some of them poke up, fire hydrants. There are hundreds of fire hydrants. And so previous to starting to use BuiltSpace, they would, at the beginning of the year, print 250 fire hydrant work orders as paper and put them in a file at the side of the dispatch office, and people would come in, take a few, and put them in their truck, so if they were out there, they'd go do an inspection. And they had to flush the valves and tell whether it was painted or not, and that it was in good working condition. So the logistics that we could show them, they've got 70 people on staff. They now have iPads. They can go into an area, do other work, and then say, oh, by the way, here's a hydrant that I've got 20 minutes I can do. So their time per hydrant dropped from about 60 minutes to, I think the last time I saw it was 22 minutes. So about a 70%. So when you think about all of the repetitive jobs that are done on a construction site or in an FM facility, the ability to know what was done, what needs to be done, and to share that work it's time to get rid of the piece of paper that was a work order and make it a complex service plan that can be data driven. And so we'll see more and more data driven FM, and I think we will see more and more data driven construction as we move forward. And that goes right back to procurement? Do I have the pieces that I need to build this? Do I have the resources? Is it ready to go on that site? You know, and that's all done with bums in seats right now. But I think there's oodles of opportunity to improve that.
Awesome, thank you. Any questions before we move on there? All right. Thank you very much, Rick. All right, so the last guest we have here, David Spehar from dRofus. David did come from the US, so he's our first maybe speaker outside of Canada. So thanks for making the trip, David.
No cartwheel?
Just hit the middle button. Yeah. All right. You know what? I'm actually going to take this off of here because, in case anybody didn't notice, I'm vertically challenged, and I don't want to. I have trouble if I'm behind a podium. By the way, I'm a really good sales guy. I didn't even put my name on my slide. Yes, I'm David Spehar with dRofus. I did come from the U.S. As far as my background, I'm a recovering architect. So my background is in architecture, and I was in that whole BIM design technology world for many years, and then I moved on to the dark side. So, yes, I'm the last presentation. You guys have seen all kinds of really good presentations, a lot of good slides on digital project delivery. You've been inundated with a lot of great graphics and really complex things to try to break this all down. I'm going to dumb it down a lot because I don't know about you guys, but I've hit total maximum saturation on all of this stuff today. So I'm going to use a case study though, and my case study is Netflix, and it's not Netflix as a client of dRofus's, but I want to use Netflix as a really good case study when we start talking, and I'm going to really dumb down Brittany's presentation. I don't know if she's still here. Did she leave? Oh, no, she's not here. She left. So really this is kind of think about Netflix in the terms of, as an owner, what do you have to do to make sure that you've got your maintainable asset stuff in order, right? So if you think about the very first part with Netflix, and I'm sure just about everybody in here has a Netflix account, right? When you're going to log in, right, what's the very first thing you're going to do? You're going to pick which one of the accounts you're logging into, right? Now, the very first time you open up your Netflix account, what does it ask you? It asks you all a bunch of questions, right? What type of movies do you like? You know, do you like horror movies, whatever. So it's filtering down a tailored experience for you, right? So if I log into Netflix, my experience is going to be very different than my daughter's experience, okay? But the reality is that right now, Netflix has allowed me as the asset owner in this example to be able to define what are the assets I'm interested in, right? So now if we say, okay, well, I'm going to go into my account. Well, so here's the Netflix interface. Everybody's seen this before, right? So think about this in the context of asset management, right? So the first things you got up on top is what do we have? We got an asset location, right? Is it a movie? Is it a TV show? And we've got asset categories or asset classifications, right? What are the genres, right? So when you think about this stuff and we start going to the whole idea of industry standards, right? Genres are a pretty standardized type of way of classifying programming, right? So if Netflix didn't use genres, then you're going to find stuff a way different way than if you're in Apple TV, right? Or if you're in Prime, right? So the idea is that asset category, asset classification of the genre of movies is a perfect example of an industry standard, right? I can find stuff, the same experience in any one of these platforms, right? But if I'm inside of Netflix, I can see that those are all how I can find my stuff, but then right away it gives me the stuff that I know, that it knows I'm interested in, right, in my dashboard, right? So each one of these programs is an asset, and it has its name, right? So if I go ahead and I click on one of these assets, and Saving Private Ryan happens to be one of my favorite movies, so what do you see when you go into Saving Private Ryan and one of the movie that you select here on Netflix? You see a bunch of asset attributes, right? You see the cast, you see the genre tieback. This movie is violent, it's gritty, don't judge me. And then this other one is really interesting. Last day to watch on Netflix, right? June 30th. What can that be? That could be warranty information, right? So if you start to think about, kind of all these complex topics that we've discussed and trying to figure out how to navigate all this as an owner, dumbing it down to Netflix, I like to take really complex things and make them simple. If you think about it in the context of Netflix, it might start to make a little more sense, right? And then one of the other cool things is that, all of these are links, right? So if I go ahead and I click on Tom Hanks, that asset attribute, what's that going to do? It's going to give me a list of all the Tom Hanks movies. So shared attribute data across all of these different attributes, right? So this is all kind of going towards this idea of when you start thinking about digital project delivery, it's really all about, again, we talk about the owners. It's really about the owners defining what assets are important, how are they going to classify them, why is that information there? Because you need to find it for these very specific reasons, right? So if we think about that now in our world, and I had to throw up a diagram like everybody else does, but the reality is if you talk about data standardization, and we've had a lot of conversations around that today, pretty much every owner has some level of design standards and asset requirements, right? PDFs, specifications, some type of information for for teams to start, right? They're kind of defined requirements. And then the idea is that information is going to be used by the design team and the construction team, and you want that pass-through of that information to go into operations, and then the feedback loop so that this whole thing is constantly evolving, right? That's kind of like the holy grail of this. So why does it work for Netflix, but it's not working for us, right? Well, I talked to a lot of owners, I talked to a lot of teams that are implementing our software, and I'll do the sales pitch in a minute. But the reality is that there's kind of two big issues the reasons why we can't get to Netflix. The first one is the owners don't have a defined data standard, right? So that movie genre, owners aren't giving the teams a movie genre list and say, hey, this is the way I want you to classify your assets, right? That data structure, that is not there. So if you think back to Netflix, all of that information, the way you navigate it, that data structure isn't given to the teams from the very onset. So owners, unfortunately, that's on you, right? The other real problem with why we can't get to the Netflix world and where we are today is we are relying on data gathering, and we heard a lot of presentations from our design and construction friends about the effort that goes into gathering and capturing all this data. And we're relying a lot of this information to come out of the models, right? Unfortunately, that is the weakest link in this whole chain, is that we're relying on data to be pulled out of multiple data sets. We've had the conversations time and time again today about design models and construction models and how do we reconcile the differences between them. But the reality is that is the source that owners are relying on to get all this information into operations. So if you think about it, right, we have very poorly or not very clearly defined data structure and data categorization, and then we're relying on the consultants to provide the information for that ultimate feedback loop. So, what if Netflix did that, right? Okay, so what if Netflix said, okay, well, we're going to have all our different movie studios, content providers and everything, give us all your movies, give us all your programming, right? We're not going to have any defined data structure around it. Genres, what are genres? We don't care about that, right? What would your Netflix experience look like, right? I've just got every single movie or every single program that's available to me, and if I search, and I just search show, this is what I get, right? So all of a sudden, all of those assets suddenly become kind of useless or hard to navigate. The other issue is, what if Netflix said, all right, we're not going to define our data structure. We're not going to control that data. We're going to rely on all the movies, the production studios and everything. You guys take your best guess at giving us what we want, and then we'll put it into our platform. Well, all of a sudden, if I click on Tom Hanks, I'm getting my favorite movie and one of the movies I hate in the world most, Dumb and Dumber, right? That's because it's bad data that's coming from other sources. So if you think about in the terms of how do we get to, how do we get away from this type of situation? And you talk about all the challenges that we have. Why can't we get to the Netflix thing? I'm not going to read through all these, but most of these have been discussed quite a bit today as far as what are the challenges that they're going to keep us from getting there. But the reality is, now warning, this is the sales pitch. So this is where dRofus comes in. And for those of you that aren't familiar with dRofus, we are a database, but we are a planning software. And we're unique because we are a planning software where you can predefine as an owner all of your design and asset requirements inside of a central database, and those requirements are predefined and templated so that that information can then be used to plan your projects. And as those projects are planned and as they evolve, more information is layered on top as the design teams get involved, as the construction teams get involved. But the reality is that we're the starting point for owners to predefine everything that they need to plan and build their buildings. And what I mean by that is you can see everything from all the room attributes, all the equipment that goes into rooms, all of the design and functional requirements for rooms, air changes per hour, occupancy, all that type of information, and then all the systems that connect everything. So at the end of the day, the idea is inside of dRofus, all of that information is structured. We are a structured database and categorized, and it's tailored to the owner so that the information they need sits inside of dRofus, and then it's connected to models. We have ArchiCAD and Revit plugins so that the information then can be essentially informing the models instead of relying on the models to provide the information back. And that data structure is set up at the beginning, right? So, case study. So what is the dRofus equivalent to the Netflix experience if we do this stuff in dRofus, right? So the very first thing is that this is our interface. So if you think about owners defining their requirements, right? So if I log into Netflix versus my daughter logging in, it's going to be a very different experience. So everything is based on how projects are organized, and the owner defines their project organization. So functionally structured, how many rooms are in the building, how those rooms are organized, et cetera. And you can see that off on the right here, I don't have it identified, but there's all the different classifications, omni-class, all that data now gets captured inside of there, right? So you're defining your requirements as the owner. So then the next thing is defining that data structure, right? So if you think back again to the Netflix example, where are my assets located? How are they categorized? How are they named? And then what are the various classifications? So all that information is now predefined inside of dRofus in that data structure. And as the information, as assets get added, if somebody says, okay, well, I'm going to add another asset to this project, all that information gets captured and it sits inside of dRofus. And then the next thing would be to clearly define those asset attributes, right? So if I click on any asset, again, just like if I clicked on one of the movies inside of Netflix, I need to know what I need to know about that, right? So this experience is, again, tailored to the unique owner's requirements for how they want to capture that data during design and construction with the idea that that information will then be handed over at the end. Right, so it's that data ownership, if you will. So you can see we've got all this information, serial numbers, all of this type of data that's going to be then captured and then exported out. Now, we're not a CWMS platform, but we do have an open API. So we can connect to those platforms and push and pull the data back and forth, or we can do the traditional Excel exports. And then finally, we start talking about the connection to the BIM geometry because, there is value, different levels of value to different owners in the geometry side of things. But the reality is that once that information is defined inside of dRofus and all of those data standards are established, then you can make these selective connections to the content inside of the models. So instead of trying to host all of this information in parameters or shared parameters or whatever across all the federated models, it sits inside of a single database, and that single database connects to all the content in the model that's relevant, and then that has a bidirectional connection. So now the geometry lives in the model, but all the data, the important data about that asset lives inside of dRofus. And no longer are we relying on that model to push that asset data into a platform at the end, but rather the owner has predefined all that data, and the models are just there to host the geometry and validate that what was predefined up front is actually making its way through design and construction. With the idea that all the data then sits here, and now you can start to navigate it, if you will, through the connection in the geometry. So ultimately, what we're advocating for, and if we think about how we can get to that Netflix nirvana, if you will, is what's most important on the owner side, and again, for whatever owners are in the room or virtually, what is most important, and I think that has been a common theme today, is data standardization, structured data, defined classifying methods of, defined ways of how you want to classify your assets, and defining what those assets are and all the information that's needed. So you can have all this other stuff, but in the center of it for your design and asset requirements needs to be those data requirements. And, you know, obviously I put dRofus up there because that's what I work for, but ultimately I think what I'm advocating for, and I think I've heard a lot of people talk about today, what we're advocating for, is that we shouldn't be relying on the design BIM or the build BIM to produce this information. Those should be almost consumers of this life cycle data, consuming it in a way to make sure that it's coordinated with the work that the design and construction teams are doing. But ultimately, the owner needs to own that data in order for that feedback loop to be efficient and to see those ROIs. I talked really fast because I know everybody wants to get the heck out of here. And with that, I'm done, and I will take any questions, or you guys can just leave and you won't hurt my feelings.
The Netflix example is pretty cool. Just as people are, you know, thinking. One thing that's interesting, Jared, we got a question up there, is the databases and how they're becoming very prevalent in construction. It's a little bit too nerdy here, perhaps, but you have structured databases, SQL, non-SQL, flat, and then you have graph databases. And those graph databases are really good at relationships and nodes and kind of pulling that stuff together. So like what Netflix was doing there with the relationships, that's really towards that side. All right, Tom?
Thanks. That was a great presentation. I approve of most of your movie choices. So that's, now that I know you're trustworthy. One of the things that I'm curious about was that you said that, you know, you can, instead of relying on those authoring models to push through that information to that database, it's living in the database, and you said that it can live across multiple models. So what I'm curious about, that you have a diffuser, let's say, and it exists, there's a version of that diffuser that exists in the design model and that lives in a contractor's fabrication model. How does that work, and what does that look like in dRofus? Is that considered two instances of a database location, or is that like, I'm just curious what that looks like?
Yeah, that's a good question. So basically the way that it works is that the asset, let's say a diffuser for instance, that's called an item in dRofus. And typically an item in dRofus has a one-to-one relationship in the Revit world to a family and a type. And there are controls inside of our Revit plugin and inside of dRofus as far as establishing responsibilities and establishing, so on the dRofus side, we establish who's responsible for that thing, and you can customize who those responsibilities are. On the Revit side of things, then we have this attribute configuration where we choose inside of that Revit model which attributes in that dRofus item are connected to parameters in that Revit model. And what we can do with those two different relationships is those kind of act as like a gatekeeper, if you will, for how that information flows. So a really good example is that sometimes what we may end up happening is that during design, we may connect that dRofus item to a diffuser that's in the engineer's model. But at some point when we get into fabrication, we're going to sever that relationship between the diffuser and the engineer's model, and the one that's going to be in the contractor's model is now the one we're connecting to dRofus. And really all we're doing is we're connecting the geometry. The data has not changed. It just sits inside of dRofus. So you don't get those issues of, well, we were connected to a parameter inside of this one model and now the other model doesn't have that same parameter. And so we kind of eliminate that type of data inconsistency. Did that answer the question?
Yeah, sorry, just one follow-up to that. Does dRofus have...
I can hear you, but...
Does dRofus have, because you showed me the example of OmniClass, does it have templates for all the major classifications? So if the owner wants to use, for example, and I hope this isn't a dirty word in here, but master format, right?
Yep.
Does dRofus have templates that they can switch to that classification system?
Yes, yeah. We come preloaded with all the OmniClass tables, uniformat, and the nice thing about it is that you can manage multiple classification systems in parallel. which is really, really nice because the asset just knows, I just know I'm a thing, and then I can assign 20 different classifications to it. Yep. Any other questions?
Is the process automated for linking the elements in the 3D model?
Yes and no. Well, short answer is ultimately yes. Once. So once an element inside of Revit holds the unique identifier that connects it to dRofus, it will automatically always connect. We do this automatic syncing. Once it's connecting to a new element, you'd have to manually do that connection the first time. But once that connection is made, it will follow that thing anywhere it goes. Even if you take that family out of that project and put it into a different project and connect dRofus to it, we'll look for it and we'll say, oh, I know you, and we'll automatically connect to it. Did that answer the question? Any other questions? Nope. Anything online, or did they all bail? All right, cool. Thank you.
Thank you, David. All right, everyone.